One of the first photographs of the James Webb Space Telescope was of a galaxy known as Glass Z13. This galaxy has the distinction of being the oldest galaxy ever recorded by scientists, having formed barely 300 million years after the Big Bang. Since the 11th of July, when it began operating at full capacity, the telescope has already astounded scientists with the clarity of the photos it has produced and the amazing discoveries it has made. Get ready to find out how the James Webb Space Telescope has already formed a picture spanning an area of the sky equal to 1/5 of the Moon's diameter, and how it has shown us Jupiter's rings in a way that we have never witnessed before. Welcome, and you are watching Technology Zone, where the home of technology resides. In comparison to the Hubble Space Telescope, the James Webb Space Telescope offers several benefits. Webb functions at a distance of around 1.5 million kilometers from our planet, which is almost 4 times farther than the Moon is from the Earth. Images captured by the Hubble Telescope, which is located 547 kilometers from Earth and functions there, are not impacted by space stations or satellites because of the distance between them and the telescope. In addition, the Hubble Telescope performs the majority of its observations in the ultraviolet and visible light spectrums. Both the NIRCam and the MIRI on board the JWST are designed to observe the close and mid-infrared spectrums correspondingly. John C. Mather, an astrophysicist, believes that the telescope has a great deal of power. It was able to identify a bumblebee flying around in space at the distance of the Earth from the Moon. The telescope's infrared vision enables it to see all the way to the edge of the cosmos, where some of the universe's most ancient stars and galaxies reside. The Hubble Space Telescope cannot see through the thick layer of gas and dust that envelops many planets, galaxies, and stars, but the James Webb Space Telescope can see through everything as clearly as an X-ray. One of the most notable distinctions is the diameter of the mirror on the JWST, which is 6.5 meters. It has a much greater capacity for absorbing light and is the most massive mirror that has ever been launched into space. It is approximately 3 times as huge as the 2.4-meter mirror on the Hubble Space Telescope. Because of the one-of-a-kind technology that the JWST has, the first photographs it captured were apparent. In fact, JWST could clear out even dimly lit elements. This picture provides a glimpse of the early cosmos that is both more detailed and more distinct than any other photograph to date. JWST was able to take the photo in only 1 day, but it took the Hubble Telescope many weeks to acquire photographs of a comparable in-depth region. The JWST's deep field picture reveals thousands of galaxies in its range of view. You can make out in the center a collection of galaxies that are a component of a larger galaxy cluster that goes by the name SMACS 0723. The combined mass of these galaxies works as a gravitational lens, distorting the appearance of light rays coming from more distant galaxies that are located behind them. Many galaxies are tiny and very dark, thus no telescope has ever found them up until recently. The JWST was designed considering our solar system as its base of operations. Jupiter is seen here as it appeared when the image was taken through the telescope. Despite the fact that the telescope was still being configured, the researchers opted to take a picture of the gas giant regardless. Since that time, the planet has been the subject of a great deal of photography. Researchers were able to evaluate the true capabilities of JWST using this method, and the results were far above anyone's expectations. The James Webb Telescope successfully provided sharp images of the planet's recognizable stripes, which are caused by various complicated atmospheric processes. It also took a picture of the Great Red Spot, a gigantic storm with unknown origins that was 16,000 kilometers long, 10,000 miles broad, and had the possibility of consuming the whole planet. Jupiter's moon Europa is visible on the left side of the photograph, and there are also pictures of the planet's other moons, Thebe and Metis. JWST was also able to get images of the planet's ring system. Jupiter does in fact possess a number of rings. Finding and documenting the gas giant's pale rings is a very challenging endeavor, because they are almost impossible to differentiate from the other brilliant objects found in space, notably Jupiter itself. After this, the telescope turned its focus to the very remote exoplanet known as WASP 96b, which almost immediately began producing astounding findings. Astronomers made the discovery of the planet in the year 2013, and it was found in the constellation Phoenix. They came to the conclusion that it is a giant gas planet approximately 1,150 light-years distant from our home planet. It has a diameter 1.2 times larger than Jupiter's, while having a mass that is less than half of Jupiter's. As a direct result, the exoplanet has the appearance of cotton candy. It orbits far closer to its yellow dwarf than Mercury does to the Sun because of the difference in its radii. This causes temperatures on Earth to rise to almost 1,000 degrees Celsius. Clouds and haze were discovered to be present in the atmosphere of the planet by the JWST spacecraft. Additionally, it found indications of water, such as the existence of specific gas particles in the atmosphere of the Earth which it discovered. For the previous 2 decades, Hubble has been looking for water, but 2013 was the first time it could detect any evidence of it. JWST, on the other hand, had made an important finding almost immediately. This is fascinating, but it would not compare to the excitement of discovering extraterrestrial life forms on WASP 96b. However, astronomers believe that the first step on this journey is the identification of physiologically essential molecules, such as carbon dioxide, water, oxygen, and methane. If the telescope detects similar compounds on rocky planets as well, then it would be a clear hint that we should start searching for indications of living organisms there. It would be less apparent if the telescope found comparable substances on gas giants. Now, in another picture obtained by the JWST, you can observe the Southern Ring Nebula, which is situated 2,500 light-years away from Earth. A star on its way out of existence is surrounded by a gas cloud that is growing, and the star visible below is the one responsible for creating this cloud. At least 8 levels of dust and gas have been expelled by it over the course of thousands of years. These emissions are then mixed by the brilliant center star, which creates intricate rings of planetary nebulae while simultaneously penetrating them with its light. Additionally, this is how the ground sunshine fills the spaces between the clouds. In the past, Hubble has also provided beautiful pictures of the Southern Ring as well as a lot of other nebulae. It demonstrated to us that these are not only blobs of gas, but rather multicolored and exceptionally complicated systems. However, JWST performed an even better job since it captured not only a crisp picture of the planetary nebula, but also a vast expanse of space beyond it that was packed with a range of galaxies. One of them is represented by the glowing silver flight that can be seen off to the left. When contrasted to the picture obtained by Hubble, you can see how much more detailed the one received from JWST is. Another distinction is that the bright stars in the photo taken by Hubble have 4 beams, but the brilliant stars in the image taken by JWST have 6 points of light. This is because the Hubble telescope has a circular lens in front of which 4 extensions suspend a secondary mirror. On the other side, the JWST lens consists of 18 different hexagonal mirror fragments. The James Webb Space Telescope brought this incredible picture of cosmic cliffs, which also unearthed some brand new information. Within the Carina Nebula, this is the boundary of a young star-forming area given the designation NGC 3324. The perimeter of the nebula was shaped by the intense ultraviolet radiation and stellar winds produced by incredibly massive and energetic newborn stars. Once again, Hubble just generated a significantly more precise picture, which is particularly visible when the photographs from both telescopes are layered on top of one another. This astonished the experts. Dots that seem on fire may be seen in the background of an image taken by the James Webb Space Telescope. They are not stars but galaxies that are very far away. The consistent radiation from newborn stars is responsible for the emission of hot ionized dust and gas from the nebula, which gives the appearance of a blue haze rising from the celestial mountains. If you found this video informative and exciting, consider giving it a like and subscribe to our channel. Also, hit that notification bell to be constantly updated with our upcoming videos. You can visit our channel for more content of the likes. And again, this is the Technology Zone, and see you guys in the next one.